All right, we're going to look at some graphs here, and I want to remind you of some general patterns to look out for. And if I was graphing something, say for example x squared, and you've probably seen this before, x squared, if I were to graph x squared, if this was a function, it would make this parabola shape. Okay, now, and that's a pattern that I want to look for. X squared makes a parabola, and what you're going to notice is that's an even number. X squared to the second power, that's an even exponent. If I were to do another even numbered exponent, like let's say x to the fourth power, that's an even number, you'll notice some similarities. They're not exactly the same shape. One, x to the fourth, has a little more curve to it. And these aren't perfectly accurate graphs. I'm just sketching these graphs. But x to the fourth power, they both, you'll notice, they're both even numbered exponents. They both open up in both directions, left and right. They have a very similar pattern. And as those exponents get bigger, one thing we'll notice is, let's say this next one was like x to the eighth power. It's going to have that same general shape. It's just going to have more curves to it as the numbers get higher. But you'll notice they should always go up in both directions. That's how I can tell, and that's one of the patterns we want to recognize is look at this degree, look at the exponents that we have. If they're an even numbered exponent, the graph should go up in the same direction on both sides. Okay, it's either going to go up like this, or let's say, what if I had a negative exponent? Like let's say I had negative x squared. It's going to make the same shape. The only difference is when they're negative, they flip. Okay, so negative x squared is going to flip down, and the way I used to remember this is if it's down, if it's negative, negative numbers go down like a frown. Okay, if it's negative, I want to look for something shaped like this. It's so easy. It's easy to forget which way these are supposed to open, up or down. But if it's negative, it opens down. If it's positive, just like positive people are, it's going to open up like this. Okay, so kind of helps us remember what it's going to look like. Now, these are even numbered exponents, still what I'm dealing with. So if I were to say negative x to the fourth, it's going to open down. It's going to look just like positive x to the fourth, but it's flipping and it's opening in a different direction. Okay, so we need to know kind of what we're looking for here when we're talking about positives and negatives, be able to differentiate between the two. If it was positive x squared, it opens up like a happy face here. If it's negative, we know that it's going to open down like a frown. Okay, and that's the only way it doesn't change the shape, it just flips it. All right, and now I want to look at odd numbers. If I have x to the third power, now this is positive x to the third power, it's not going to open up in both directions. It's going to open down to the left, but it's going to open up to the right. So it doesn't make a parabola if it's odd. Instead of going in the same direction on both sides, it's going to go in different directions. And these are positive, so just like a positive slope, if I'm going left to right, these are all going uphill from left to right. They're positive numbers. The slope's going to go up as we go from left to right. If I said x to the fifth power, that's an odd numbered exponent. It's going to have the same general shape. It's just going to have more curve to it. Okay, so you'll notice the end behaviors are the same on both of these graphs. They're odd numbers. They go in two different directions. As the numbers get higher, they do have more curve, but that's what we're going to expect to see is where do they go? They go in two completely different directions. Now, if I were to make these negative, it's just going to flip that graph. So if I were to, let's say for example, if I had negative x to the third, it's going to open down as I go from left to right. So this is like a downhill slope right here. If it's negative, we think of it as a slope, it's going to go downhill from left to right. So when you're looking at a negative versus a positive, the shape is exactly the same. The only difference is positive opens up to the right, negative opens down. As I'm going to the right here, I'm going down. As I'm going to the right, if it's positive, I'm going up. Okay, so that's the difference in those two, and we want to be able to recognize that because we're going to be describing what we call the end behavior of a graph. And for me to describe that, I need to know where this graph is going to go. Okay, so for example, if I were to graph x squared and I said, give me the end behavior of this graph. Well, for you to give me the end behavior of a graph, you have to know what it's going to look like, right? I have to know that x squared, if I put that on this graph, I have to understand that it's going to look like this, kind of. Okay, so I'm just sketching this graph. When we talk about end behavior, I'm looking at these arrows. Where does this graph go on the left, and where does it go on the right? Well, if I'm talking about to the left, it goes up, and it's going, because these arrows are headed up in an upward direction, but it's also kind of going to the left, all right? And that's important for me to understand that. It's going up to the left, but over here on the right-hand side, it's going up. It's going up on both sides, but on this side, it's kind of going to the right. That's the direction that this graph is going in both ways. It's going up left, and it's going up right. And we use positives and negatives to show that, because on this graph, if I'm going to describe the end behaviors, we have an x-axis and a y-axis. All right, the y-axis is always the vertical axis right here. Okay, so I'm always talking about the vertical axis if I'm talking about y. And another way to describe the y-axis, and what we'll be actually calling it in this when we're talking about graphing these, is we will call the y-axis f of x. Okay, that's the y values. If it's a function, f of x actually is the same thing as y. So we use those interchangeably. But when I'm describing end behaviors of a graph, I will call the y-axis. When I'm talking about is it going up or down, I'll say f of x. Okay, and we're going to be talking about the x-axis. We just call that x. But let's say I'm describing where the end behavior of this graph is going. Well, I'm going to use a positive to describe up, negative if it goes left, and over here, positive if it's up, and if it goes to the right, that's also a positive direction. And so we're talking about up and left, up and right. Those are the directions I'm talking about with this graph. So if I'm going to describe up, we're going to say f of x. As f of x approaches positive infinity, all right, so what I'm talking about over here is when I'm saying positive infinity, I'm saying that this graph essentially goes up forever, but the x values, as it's going to the left, over here on this left-hand side, the x values are actually going, it'll say as x approaches negative infinity. Let me slide this over a little bit. All right, so as this graph goes up forever, it also goes left forever, and we're calling that negative infinity. So if I'm describing, and now I am just looking at this left side of the graph right here, it goes up and left. That's the first thing I'm going to describe. All right, so you want to look at the signs. It kind of looks confusing at first, but all I'm saying is it goes up and it goes left. That's what those two signs tell me. That's what I really want to be able to pick out of this, is I know one side of this graph has a positive and a negative because it goes up and it goes left. Now the other side, if I'm looking at this right hand side of the graph over here, it goes up to the right. So I would say, all right, well, on that right hand side, the y values are also going up. So we'd say positive infinity, they're going up forever. And as they're doing that, x is going towards positive infinity. So I'm just looking at the signs. Don't worry about all the x's and the infinities and all that stuff. Look for the signs. I know that on the other side, on both sides, they go up. You know, f of x goes up on both sides. But the other side goes to the right. That's why I have a positive and a negative in the top, and a positive in the bottom. That's how I would describe the end behavior of this graph. So I'm just looking for the signs. I want to show you kind of what that's going to look like on a test question. All right, so typically when you see this on a test, it's going to look something like this. They're going to give you a function, but all I'm really looking at if I'm describing the end behavior is this leading degree. So this would be the graph. I would kind of just ignore this other stuff. If I'm just describing end behavior, all I'm looking at is this highest degree here in the front, and it's x to the third. If I know what shape that makes, I know it's shaped like this. It's x to the third. It's going to go down on the left, up on the right. So the way I'm describing this is I know it goes down and I know it goes left. Over here on this other side, it goes up and it goes to the right. Okay, so if I'm describing what that looks like, let me first just start by describing this side over here to the left. All right, it goes down. Down is a negative direction, and it also goes left. So when I'm describing that, I'm using two negative directions. So I'm going to say as f of x goes towards negative infinity. This thing goes down forever over here on this side of the graph. Okay, so as it goes down forever, the x values, so as x approaches negative infinity. So what I'm looking at on that left-hand side is for the signs to both be negative. So the y values, f of x, they're going down. So are the x values, they're going down. Now, if I'm talking about the other side of this graph over here, it's going up to the right. Those are both positive directions, just like when in the parabola on the right-hand side. It's going to go up to the right. So I would say here f of x is approaching positive infinity as x approaches positive infinity. Those are two positive directions. When we talk about up and we talk about to the right, those are both positive directions. So I just want to be looking for the signs that match. Where is this side of the graph going? Well, it's going down and it's going left. Okay, and where's this other side going over here? If I'm looking at the other side, it's going up. That's positive, and it's going to the right. That's positive. So I'm looking for signs that match that specific graph. What would it look like? So on a multiple choice test, it's going to look kind of like this. So you're going to be given the function, and they're going to ask you to find the end behavior that matches that specific function. So all I'm looking at for this end behavior is that leading exponent. This is x squared. Right, if you know what that's going to look like, I know that x squared opens up to the left and up to the right. So I know I'm just look for the signs. Okay, I know that up and left is going to be a positive and a negative. I know that up to the right is going to be a positive and a positive. I know that this graph goes up on both sides, so I would be looking for an answer choice that tells me the y values are both going up. F of x goes up on both sides of these graphs. Okay, and that's really enough on this in this case to figure out which answer choice it is, because you look over here, this is positive and negative. That's definitely not, it's not going up and down, it's not odd. If it's even, it's either going to go up on both sides or down on both sides. And since this is positive, I know it's going to go up on both sides. Now, it is going to go up to the left. So that's why I need to see that negative right here. But it's also going to go up to the right because it isn't. And anytime I have an even positive exponent, whether it's squared, fourth, sixth, it's going to follow this exact same trend as far as the end behaviors are concerned, as long as they're positive. Okay, so that's how we would identify the end behavior if it was a multiple choice test. Just look for the signs once you recognize where these graphs are actually going. Okay, the signs are just simply telling us the direction that the end behaviors are going. So look for the signs. Don't let this overwhelm you that it looks crazy, all this notation. This is just simply directions telling me up or down, left or right, based on the sign. And I'm just going to look at the end behaviors of the graph to figure out where is it actually going. Okay.